Another nice thing about working with algebraic vectors is that the fact that we can represent it with ordered pairs, or we have a numeric way of dealing with the vectors, makes it much easier to now add, subtract, and multiply by a scalar. Because instead of trying to just draw them and keep the angle and the length the same, and then use the laws to create either a triangle or a parallelogram and cosine law to find the resultant and remembering to get the direction, now we're going to be able to represent everything with ordered pairs. So if we have a vector u that's represented by 3, negative 6, 1, and a vector v that's represented by negative 2, 0, 8, we want to find w equal to 3u minus 4v. So 3 and u are scalars, which means I can just do scalar multiplication. So 3u becomes 3 times 3, negative 6, 1, subtract 4 times negative 2, 0, and 8. So the distributive property means I can distribute those scalars in. So 3u's is really the same as 9, negative 18, 3, subtract. 4v's is going to be negative 8, 0, and 32. Now I'm just going to perform the subtraction. 9 take away negative 8 is 17. Negative 18 take away 0 stays negative 18. And 3 take away 32 is negative 29. So I've found w without having to draw and manipulate vectors. I can work with the ordered pairs. Number 2, show that these 3 points are collinear. Collinear means line on a straight line. Now I could draw them accurately, but really I just want to see. So I want to see, is the vector from A to B, does the vector from A to B have the same direction with B to C? Or I can also say, does the vector from A to B have the same direction as the vector from A to C? Because if these are collinear, then I have to maintain the same direction along. With point-to-point vectors, the vector AB is going to be represented by the ordered pair I get when I backwards subtract. So negative 3 subtract 5 is negative 8. 4 subtract negative 1 is 5. So there's a vector that represents going from A to B. It's the difference between their coordinates. Now again, you could do B to C. I'm going to choose to do A to C. And again, I'm going to backwards subtract. So 13 subtract 5 is going to be 8. And negative 6 subtract negative 1 is going to be negative 5. So now I want to ask myself, are these parallel? Parallel vectors are basically multiples of each other. Since AC equals negative 1 AB, they are collinear or parallel, and ABC have to lie on the same line or are collinear. This doesn't have to be a negative. This could be 2, it could be negative 3, it could be a fraction 1.5, but as long as there's a multiple, or you get the same thing when you divide. If I do 8 divided by negative 8, I get negative 1. Negative 5 divided by 5, I get negative 1. If I got different answers for those divisions, then these aren't parallel. If I get the same division each time, then they are parallel. And I've proven the 3 points are collinear by looking at parallel vectors. Now the last question. A, B are opposite vertices of a parallelogram, O, A, P, B, and O always stands for the origin. Find P. Now, the good news is I don't really need to draw this in 3 dimensions. I can orient my view, so I'm just looking at the parallelogram straight on. It's only important that I put A and B opposite each other, and then I have O and P. I'm going to represent P by X, Y, Z because it's the one I don't know. O is 0, 0, 0. A is 1, negative 3, 5. And B is 4, 8, negative 2. So what I know about parallelograms is that opposite sides are equal and parallel. If I think about that in terms of vector, the vector OA has to equal or be the same vector as BP. And order is very important. I have to start in the same spot and go. If I went opposite, these would be parallel vectors, but they'd be opposite in direction. I want to create 2 identical vectors because now vector OA is just A subtract O, but because O is the origin, it just becomes A. the vector BP is P subtract B. So it's going to be x minus 4, y minus 8, and z plus 2. For these two to be equal, the x-coordinate, the y-coordinate, and the z-coordinates have to be the same. So I'm really just going to set up 3 little mini equations. One has to be the same as x minus 4. Therefore, x has to be 5. My second equation, negative 3 has to equal y minus 8. So negative 3 has to equal y minus 8. So y equals 5 as well. And then my final, 5 equals z plus 2. So then z is going to equal 3. So therefore, the coordinates of P are 5, 5, and 3. So backwards subtract finds the vector between 2 points, and equal vectors have to be the same, and we can use backward subtraction and equality to find similar vectors on this parallelogram.